All right, if you have two muscles on the opposite side of the joint and you contract them to an equal degree, or they generate the same amount of force, let's say your biceps and the triceps generate the same amount of force, what's going to happen to the elbow joint? It's not going to move. So what's a term for that? Besides stuck?
Static or isometric.
Right, so it would be, obviously it would be static because it's not moving, but if you were like this, you'd have rigidity. Okay, this joint is rigid. Okay, so that's kind of a medical term. So you don't want rigidity, right? If my goal is to generate some kind of movement, in the case of the stretch reflex, I'm trying to get the spindle off a stretch. And the way they do that, in our example with the knee, is what? Cause this muscle to shorten, and then I get extension. Okay, and then hence then the spindle is no longer being stimulated, or it's no longer being stretched. What happens if hamstrings are contracting to an equal degree? Well, I'm not going to get movement, am I? Right? So the spindle is going to be just kind of left hanging out there. So I want to make sure that in order to relieve the stretch on the spindle, I actually get muscle contraction that causes motion, or shortening of these fibers. Okay, I want to get the stretch off of that spindle. And the way to do that is actually shorten these muscle fibers. Okay, so I want some kind of system to ensure that the muscle on the opposite side of the joint, or the antagonist, isn't also stimulated. Okay, I want to make sure that I'm getting this movement as opposed to no movement at all. All right, so how can I do that? So let me try to draw our little stretch reflex. Okay, I have extrafusal fiber. I have a little muscle spindle. Okay, Okay, my afferent goes in, synapses on our alpha motor neurons in the spinal cord, goes back to the muscle, and these are plus signs, causes muscle contraction. Okay, so that muscle is doing its job. It's going to contract or shorten. So let's draw this as the muscle on the opposite side of the joint. Okay, so I want to make sure that I actually get shortening of this muscle. Okay, my goal is I don't want this muscle on the opposite side of the joint. In our example, the hamstrings, I don't want those hamstrings to contract. Okay, because if both this muscle and this muscle are contracted, I'm going to be rigid. I'm going to be stuck right in this position. I don't want that to happen. So what we have in our spinal cord is a process to ensure that that doesn't happen. Okay, so part of the same signal that excites the alpha motor neuron of the muscle that was stretched also ends up causing inhibition of the muscle on the opposite side of the joint. Okay, so what I'm trying to draw here is there's a little branch of the axon that goes over to the alpha motor neurons of the muscle on the opposite side of the joint, and it inhibits those alpha motor neurons. So that guarantees relaxation of the muscle on the opposite side of the joint. Okay, so while it excites its own alpha motor neurons, the same muscle spindle signal inhibits the muscles on the opposite side of the joint. All right, does that make sense? So what is that process known as? So it's known as reciprocal inhibition. Okay, so you can think of joints as one over, agonist, antagonist in this example. And so then you have reciprocal inhibition. So basically the muscle over the joint gets inhibited. Or I guess in this case underneath the joint if we're talking about the biceps. Okay, so this process where we inhibit the muscle on the opposite side of the joint from the muscle that was initially stretched is known as reciprocal inhibition. Okay, I am inhibiting that muscle, and what does that do? That guarantees that I'm going to get a shortening of the muscle that was initially stretched. Because this muscle is not going to fight me. Okay, it's going to be relaxed automatically, allowing this muscle to contract, hence I'll get the shortening of this muscle. And that relieves the stretch on the muscle spindle. Okay? Does that make sense to everybody? So you've got a built-in process that's at the spinal cord level that's going to ensure that the muscle on the opposite side of the joint doesn't interfere with what you're trying to accomplish. In this case, shorten a particular muscle to relieve the stretch on the spindle.